So for the survey data, we are going to use the pandas to read the CSV file again, but this time we are going to load with a different RMSP data type. For survey data, we use rmsp.survey data, and then we can use pd read CSV to load our data. So if I press tab here, I will see a list of files contained in that folder, and we are looking for survey.csv, and I can capture the output of that in the survey variable. All right, so this will be my survey, but again, we need to know what kind of metadata we need to specify. It's quite useful actually to just load the data first, if it's a small data set, and take a look at the data that's inside and use that information to fill our metadata. So if I press Shift Tab, I can see the documentation for the survey data. And in here, I see that I have drill hole ID, DHID, depth, azimuth, and inclination. So those are my metadata. So starting with drill hole ID, so I can copy from here. And then I have depth, which is this column. And then azimuth, which is this column. And inclination. Note that for RMSP, the inclination is measured from the horizontal to downwards in a negative angle. So 0 would be in a horizontal, and then straight down would be -90. So if I run this cell now, I have my survey. I can say get meta true, and take a look at all the metadata, if they exist, if they are required. And this time I'm going to omit this step because it's not quite required. What I'm going to do is just copy that check value range and set the show meta to true. So we can take a look at all the information within that data frame. One thing that I haven't mentioned with the caller data is that we have access to the metadata of each object by doing, for instance, survey.dhid. It will give me access to the value for this metadata. So if I run this, it's just going to show the column name for the drill hole ID. And I can do the same for the depth, and I can do the same for the azimuth, and I can do the same for the inclination. So this is a easy way to access the metadata. So I could access this column in my survey just by using that metadata information. Now we can move into validating the survey data frame. So for that, we just do survey dot check, and if I press Shift Tab, you're gonna see more of similar arguments that we had for caller. We have the report argument, and we can have access to all the same 3 types of report: summary, Boolean, and string. And we also are able to disable the warnings by ignoring the warnings and setting that to true. We can see that for survey data, the checks are slightly different. We have checks for duplicate records. So if a data location has the same drill hole ID and the same depth within this data set, that means there is a duplicate. So it will highlight that issue. It will check for any missing values on the metadata. It will check for invalid azimuth values. it will check for invalid inclination values. It's gonna check for the invalid depth values, and also it's gonna take a look at the deviation of path, also known as dog leg severity, and it will highlight any possible problematic data that contains that. And of course, it will check for mixed data types. Again, if your data frame has a column that contains strings and numbers at the same time, that is considered to be problematic, and it will flag as something to be checked. So let's just run this and see what we get. So we get here two different warnings. One warning is saying that, okay, your survey file has 101 azimuth values outside the 0 to 360 bounds. So that's not necessarily a problem as long as it's still a valid azimuth, but it's just highlighting that to us. So if I do, for instance, a Boolean report and get the result table, now if I do a table head, and let's say I want to see all the survey locations that has invalid azimuth. So if I access that column here, it returns a true or false array, which in turn I can use to slice my table, and this will return all the drill holes and depths where azimuth is outside the range between 0 and 360. Turns out that the azimuths are not a problem here. It just means that if it's negative, it's gonna be 360 plus this number, so resulting something slightly smaller than 360. So in order to fix that, we can actually just process our data. So we are gonna see that the survey at the locations where survey dot azimuth, which is our metadata for the azimuth, is smaller than 0, then we are gonna set these azimuth values to be added 360. So hopefully this will fix all the issues with the negative azimuths, so we can actually run this again. So now I want to get a summary. So now we just have this deviation of path that we could look in 3D later on in order to validate. But for now, I'm not too concerned with that. So let's just ignore warnings, and so we can avoid the red box, and that finalizes the checking of the survey array. Of course, I could always go ahead and take a look if there is, what is the issue with this deviation, if it is a real issue or if it is actually okay.